So what do a high-speed drone, a 3D printer, and your car's anti-lock brakes all have in common? I mean, think about it. A drone, a printer, your brakes, they seem like they're from totally different worlds, right? But believe it or not, they all share this hidden design philosophy. It's kind of like a secret ingredient that makes them intelligent, precise, and super responsive, in a way that older machines they just couldn't be.
Well, that common thread, that secret ingredient, is a field called mechatronics. Yep, mechatronics. It's basically the invisible engineering magic that powers so much of our modern world. And in this explainer, that's exactly what we're going to do. We're going to pull back the curtain and see how it all works. All right, so let's dive right in. Section 1. What is mechatronics? You hear the term, but at its core, it's not just some tech buzzword. It really is a design philosophy. And it represents this huge leap in thinking, a leap that took our gadgets from being simple mechanical tools to becoming these intelligent systems that can actually sense, think, and act all on their own.
Okay, so here's the textbook definition. It says it's an interdisciplinary field. But what does that really mean? The best way to think about it is like a fusion, a mashup. It's the point where the physical world, the mechanical parts, meets the smarts of electronics and the logic of computer control. And here's the key. All these pieces are designed together, right from the very beginning. That's the whole systems thinking part of it. The goal is to create one single, cohesive, intelligent machine.
The name itself gives you the biggest clue. It's literally a mashup of mechanics and electronics. So the mecha part? That's the machine's body and muscles. We're talking gears, motors, the physical frame, all the stuff that lets it move and actually do work. And the tronics part? Well, that's the senses and the nervous system. The sensors are gathering all this information, and the signals are the nerves telling those muscles exactly what to do.
Okay, Section 2. The 4 core ingredients. So, if we were going to build one of these smart machines from the ground up, what's the recipe? It really boils down to 4 main ingredients. And the secret isn't just having them. It's about how they're perfectly mixed together.
So here they are. First up, the mechanical systems. This is the skeleton and muscles, right? The physical body. Then you've got the electronics, which we said is like the nervous system, sending and receiving all those signals. Next, the control systems. Think of these as the reflexes. They use feedback loops to make tiny adjustments and keep everything stable and on the right track. And finally, number 4, you have the computer or software. This is the brain. It processes all the data, runs the main program, and usually gives us the human-machine interface, the HMI, which is just the screen or buttons we use to actually interact with the machine.
Now, you don't just throw these ingredients in a bowl and hope for the best. It's a really structured process. You start by figuring out what problem you're trying to solve. Then you brainstorm some concepts, you model it out on a computer. But honestly, the most critical step of all is integration. That's where you make absolutely sure that the mechanical parts, the electronics, and the software are all speaking the same language and working together perfectly before you even get to test.
All right, Section 3, let's talk about the brain of these systems. We're going to zoom in a bit here, because in the world of big-time industrial automation, I'm talking factory floors, power plants, the heavy-duty stuff, that brain has a very specific name. It's called the Programmable Logic Controller, or PLC for short. And let me tell you, this thing is the absolute heart of modern industry.
And that's not an exaggeration. People call the PLC the backbone of industrial automation for a very good reason. See, a PLC isn't like your desktop computer. It's a special kind of computer, built to be incredibly tough and super reliable. Its whole job is to orchestrate everything happening on a factory floor. It's the device that takes all this mechatronics theory we've been talking about and puts it into action, 24/7, without a break.
So what's actually inside one of these things? What makes a PLC tick? Well, think of it as a special modular computer. It has a CPU, that's the brain that runs the program. Then it has input modules. These are like its ears, listening to signals from hundreds, sometimes thousands of sensors and switches. Then it has output modules. That's its mouth, sending commands out to motors, lights, and valves. Throw in a rock-solid power supply, and the whole system is designed to do one thing: execute a program written by an engineer flawlessly millions and millions of times. Okay, time to zoom back out.
We've seen the theory, we've looked at the PLC brain, so where else does all this mechatronics stuff show up? Well, the short answer is pretty much everywhere. Let's do a quick run-through of some examples you'll definitely recognize.
First, the big one, manufacturing. This is the classic example. The incredible precision of a CNC machine cutting metal. The synchronized, almost dance-like movement of an assembly line. The sheer power of a giant industrial robot. These are all pure mechatronics. And most of them are run by those PLCs we just talked about.
Next up, the automotive world. The robots that weld the car's frame together? Yep, that's mechatronics. But what's really cool is the tech inside the car you drive. Take your anti-lock braking system, or ABS. It's constantly sensing the speed of each wheel and pumping the brakes way faster than any human possibly could. That's mechatronics in action, literally keeping you safer on the road.
And of course, that level of precision is absolutely critical in fields where there is zero room for error. We see it in medical and aerospace. We're talking about surgical robots performing operations with superhuman accuracy, advanced prosthetic limbs that can translate a person's nerve signals into actual movement, and those amazing flight controllers that keep a drone perfectly level even in crazy high winds.
And believe it or not, it's also right there in your house. That autofocus on your camera, that's a tiny little mechatronic system sensing distance and moving a lens. Your smart washing machine that can actually adjust the cycle based on how heavy the laundry is, that's mechatronics. And a 3D printer, that's maybe the perfect desktop example of mechanics, electronics, and software all working together in perfect harmony.
But look, this field is not standing still for a second. The huge technologies that are reshaping our world right now, things like AI and the Internet of Things, they're now being baked directly into mechatronics. And that's pushing everything towards an even smarter, more connected future.
So, what's next? What does that future actually look like? Well, we're seeing machines getting connected to the Internet of Things, or IoT, which lets you monitor and even fix them from anywhere in the world. We're seeing AI get embedded right into PLCs, creating systems that can actually optimize themselves and learn from their own mistakes. And with something called edge computing, all that intelligence is processed right there on the machine, not in the cloud. And that's what's leading us to truly autonomous factories and self-learning robots that are faster and way more resilient than anything we have today.
And really, that brings us full circle to the most important thing to remember from all of this. Mechatronics isn't just about sticking different engineering parts together. It's a philosophy. It's a whole way of thinking about design that puts intelligence and seamless integration first, right from the start. It's what gave us all the amazing smart tech we have today, and it's what's building the foundation for the truly autonomous world of tomorrow.
So I'll leave you with this question. What do you think is the most exciting application of mechatronics coming up? Is it self-driving cars? Is it smarter medical devices? If you want to dive deeper into this stuff and chat about ideas just like that with other professionals and enthusiasts, a really great place to continue the conversation is the community over at mechatronicsforum.org.